All right, let's do an example. This is a 2019 summary of a sample of 276 adults. And so we're going to call the proportion that any of these situations happens, that we're going to call that its probability. So what's the probability if I pick a randomly selected person that they've never married? All right, so never married, that is this row right here. So I look, the total for that row is 85, and the total number of people is 276. So the probability that someone has never married is going to be 85 divided by 276. And the notation, if I was doing it, that's going to be the number in event n over little n, which is the number in S. All right. And this equals 0.308, which is around 31%. So around 31% of people have never been married. All right, if you know that a person is male, what is the reduced sample space? All right, so we know they're male. What our reduced sample space is going to be this whole column. So this is going to be the column of 132 males. So when I answer probabilities about what's going to happen, or what's the probability of something given they're a male, then I'm going to go to this column. My total number of possible outcomes is going to be this 132, and then I'm going to add up the number of outcomes that are actually in my event, but that are also male. All right, so what's the probability that a person has never married given they're male? All right, and according to my little rule, this is the number that are in both of these, N and M, over the number that are in male. All right, so both never married and male are these people. So this is 45, and the number of males is 132. So this is equal to 0.341. This is around 34%. So a 34% of males, all right, so we're given they're males, so the of part is going to be, this is going to be, when I have this of, this will be the given part. 34% of males have never been married, or have never married. Are the events never married, comma, and male independent? Are those two events independent of each other? All right, so how do I tell? Well, does knowing that I'm a male, does that, so knowing this, all right. So if it doesn't change the probability, then we call it independent. If knowing that it's a male does change the probability, then we say that's dependent. And we look, the probability of never married is 31.308. The probability of never marrying, given you're a male, so knowing you're a male, change that to 0.341. So it's changing it. So are they independent? No. Since the probability of never married is not the same as the probability of never married given male. So this is my answer right here. So that's our alternative definition of what independent events are in terms of conditional probabilities. They're independent if their probability, so the probability, so these are E and F, if the probability of E equals the probability of E given F, or if the probability of F equals the probability of F given E, which these are different. Right? These are not the same thing. So if either one of those, so I just have to test one, so whatever's easiest for me, then I'll go ahead and test that. And if they're equal, they're independent. If they're not equal, they're dependent.